Welcome to the Artificial Intelligence Podcast with your host, Dr. Tony Huang. Today, we're in beautiful San Francisco for the Databricks AI Summit. I'm here with a special guest, Hagay.
Hey, folks.
So Hagay has been on the show, and we're really excited to go over all of the Gen AI announcements that happened today at the keynote. So Hagay, fill me in on like the hot stuff that's happening.
Yeah, well, a lot of announcements today coming in the summit, and really lots of grounds to cover. But I think there are two actually main kind of themes where I think Databricks is really taking a very particular position on generative AI. One is, from general intelligence to data intelligence, and data intelligence is really about how companies can use their own data to build AI systems. And it's more than just general purpose AI capabilities, which are super important and are going to play a huge role in consumer space. But then for the area Databricks is operating in, which is helping enterprises build AI systems, it's really about how companies can leverage their data to build AI systems. And there are a lot of benefits to that, and that's what we found working with customers. And we can talk a bit about that. The other main theme, I think, is really, from AI models to compound AI systems. And, models have been amazing, right? All the advancement with transformer-based models and how they really created a revolution, right? In language understanding and tasks like translation, generation, but also in other modalities. But then what we've found working with our customers is that really to leverage these amazing models, you have to build a compound system, because otherwise you have models that are outputting things out of control, like hallucination and other things. And also, you're not able to produce a system that is reliable, stable, and kind of is tailored to your use case. So those are the two kind of main themes, and a lot of our announcements have been around those two themes.
Very cool. Yeah, so I agree. Like, in my opinion, whenever I talk to people, whenever they think about Gen AI, it's just they have a query, they put it into a black box LLM, and it spits out an output. And I like the way that you guys are headed towards, which is you got to think about all of the different systems that support the LLM. So the LLM is just a tiny little guy, and people are not thinking about everything that surrounds the LLM to make the system work correctly. And they're just thinking, let's just throw data into this like black box and hope something comes out
Yeah.
of it. And then a lot of times you get hallucinations, you get the incorrect answers, you don't get the correct performance that you're looking for. I love the way that Databricks is thinking about like how can we produce like the best results for like enterprise clients.
Yeah. And, I think there's one analogy, actually, shout out to Andrei Karpathy, right? A well-known, figure in our space. He, at some point, created this analogy where he compared AI systems to kind of the traditional computer architecture. With, in computer architecture, of course, the CPU is the heart of the system, but then you have all these auxiliary components that without them, right, would be no computing. And that's like, RAM for, volatile storage, the disk for long-term storage, display, inputs. And I think when I think about a modern AI system, it's really, the analogy is that the LLM is like the CPU, but then the vector database, that's the long-term storage. The prompt, right, is the RAM, short-term storage. You have inputs and outputs that, are different modalities for inputs and outputs. So, still I think a lot of the value is generating, right? A lot of the compute, most of the flops are happening in the LLM, right? The analogies of the CPU. But then without these components, you can't really build a system that is useful for people. So I really like that analogy, and I think it's definitely is spot on.
One of the key announcements was that Databricks is now offering a lot of services that are going to be serverless. Can you walk through like what the different services are, or is like everything serverless now?
Well, I think, when you take a step back from just the Databricks AI offering, Databricks has been on that route for serverless for quite some time. And our goal is that each and every service on Databricks is serverless. That's not where Databricks started, but this is where we're heading. And now when we design new systems, we start with serverless, and we try to avoid non-serverless as much as possible. So zooming into kind of Databricks Mosaic AI, which is our AI products, our foundation model APIs are fully serverless. That's the system you use for serving large AI models or accessing models that are offered on our platform. You don't have to worry about bringing your own GPUs, which are, expensive, hard to get, etc. We have pools available for you. You just need to specify or just access, basically. So if you think about inference against, let's say, a large model like DBRX, you can access it on a paper token basis, where the whole notion, right, of compute is completely abstracted away. It's just there, and you pay based on your consumption, which is number of input tokens and output tokens. And that's been kind of the model that OpenAI, right, pioneered. And I think the industry is kind of standardizing around it. However, what we found is that for production-grade application, where you care about SLAs, you care about availability, you care about latency, customers tend to want to have some kind of guaranteed availability and throughput. And the paper token usage, which is multi-tenant serving based, is not always the best case. And anyone who uses service like OpenAI knows that at some point you get throttled. At some point you get latency spikes. So to mitigate that, we're offering provision throughput, where again, the servers are kind of abstracted away, but basically you specify what's your target throughput. You get charged based on that, and we guarantee that availability under the hood through smart, quality of service controls and traffic shaping and things like that. So that's on the inference side. One of the exciting announcements also we had in this summit is our fine-tuning service. And we're really, really dumbing down the complexity around taking a large model and fine-tuning it on your own data. And that is serverless as well. And, just to share some data, like if you want to fine-tune a model like DBRX, which is a fairly large model with 132 billion parameters, or Llama 3 70B, those are big models. To fine-tune them in a reasonable time, even if your dataset is not that large, you need anywhere from 16 GPUs up to 64.
Wow.
And yeah, and we've abstracted that away. So again, there is somewhere on our cloud, there's dedicated GPU pool. You just run your job. We take care of marshalling up, spinning up these GPU nodes, installing them with all the all the software dependencies, sharding the model itself, because some of these models don't even fit on a single GPU. So I need to do tensor parallelism. Sometimes you need to do pipeline parallelism. There's a lot of complexity that we're handling for you, and you just specify the model you want to fine tune, provide a pointer to the data, hopefully in Unity catalog, and the system handles everything else for you. You don't even are aware of the notion of GPUs being marshaled under the hood, how many GPUs, how they're marshaled, etc. That's handled for you. Last but not least, again, sticking with the AI area, pre-training models. That's been, that's been MosaicML's, the startup acquired by Databricks. That's been the original product MosaicML built. And at this point, we have dozens of customers that pre-train their own large models. We've trained DBRX on this platform. We also trained the new Image AI model on that platform. And over there as well, we're completely abstracting away the compute as much as possible. So today on MCT, that's a product customers use to train their own, pre-train their own models. You can actually pre-train different versions of DBRX, all the way from a small version, 9 billion parameter model, up to the full 132 billion parameters on MCT, without having to worry at all about getting access to compute, and preparing that compute for training. And some of these jobs can spend more than 1,000 GPUs. That's all happening on our compute pool.
So like on average, like how much would a client spend to do the fine tuning?
Yeah, it's a great question. So this really depends on the amount of data you use. What we've seen with customers, you can actually fine tune, let's say, a 7 or 8 billion parameter model, like a, Llama 3 8B, with something like even 10 million tokens, which is, a couple of thousands of examples. You can get pretty good results. It kind of depends on the use case, of course. That would set you back under $200.
Oh, wow.
Dollars.
Yeah, that's very, very
Yeah.
cheap.
And if you go kind of more the higher scale of what we've seen, so maybe 100 million examples or 500 million examples, that can cost you a couple of thousands of dollars, which by itself is also not too bad, especially when you consider the outcome you get out of it is your own custom model that is really good at your specific tasks. And we've seen many cases where our customers were able to actually fine-tune a model like a Llama 370B parameter model, even smaller, fine-tune on that specific task and get results that are on par or better than GPT-4. Now, of course, if you try to evaluate this fine-tuned model on any task, it would do poorly. But on the specific task you fine-tune it for, it does remarkably well. So considering kind of the small one-time investment to what you get out of it, that's a pretty strong value proposition. We've seen super high demand for this new fine-tuning service. And we're actually now very busy to expand our GPU pool so we can support kind of the number of customers that want access to it.
So what are your thoughts on the LoRa QLoRa adapters?
Yeah. So LoRa or LoRac adaptation is, just to make sure our audience understands what LoRa means, it's a fine-tuning technique that rather than fine-tuning the entire weights of the model, factors the different weight matrices across the model. So it's a large matrix and small matrix for every layer or block. And then the fine-tuning actually only adapts the adapters, only updates the adapters. The reason it's useful is because once you fine-tune and you got this set of fine-tune adapters, you can then use the same model serving endpoint and then just swap out the adapters that are relatively very small in size. They're, I think, definitely less than 10% of the overall parameters of the models. And then you can use the same endpoint to actually serve multiple fine-tuned models. So the value you get out of it is, highly efficient serving of a lot of fine-tuned models. We're definitely looking into LoRa for fine-tuning. What we found in our initial experimentation is that the quality is not always as good as kind of full traditional fine-tuning, where you update the entire parameters of the model. And we know from working with many customers that performance and cost are definitely important, but they become important only once you hit some quality threshold. And we want to make sure that our LoRa offering, once it's shipped, is actually one that guarantees, minimal loss of quality compared to traditional fine-tuning. So this is why we launched a service initially with support for traditional fine-tuning, full weight fine-tuning. Definitely one of the things we're looking at into as next steps is LoRa fine-tuning. And some customers, like fairly large organizations, they want to have, different fine-tuned models for different use cases. And then once we have LoRa available, they can use that to serve very efficiently for, potentially even tens of different models fine-tuned from the same, base model.
So at the Databricks Summit keynote, one of the key highlights was the Shutterstock image generator. Can you walk through what that is and like what are you guys building there?
Yeah, definitely. That is also one of my favorite announcements. That was a long and hard work by our MosaicAI research team, together with the MosaicAI engineering team, together with the Shutterstock team. So this is a partnership. Shutterstock has treasure trove of image data, labeled image data. And actually, they've been licensing that data to companies like OpenAI and other companies who are using it to train their own models. Our partnership with Shutterstock is basically getting access to Shutterstock data and partnering with them to train a text-to-image model. It's a stable diffusion Excel model and have it available on the Databricks platform for Databricks customers to access it, as well as to Shutterstock customers. What's really, I think, is, there are many text-to-image models out there. And where the Databricks Shutterstock offering stands out is the commercially readiness of this model, in the sense that all of the data this model was trained on is fully licensed. It's fully owned by Shutterstock. There is no other data that was scraped from whatever sources in there. It's all Shutterstock data. It's all clean data. It's all really data that is really great for enterprises. And I'm contrasting it with, other text-to-image models out there where we don't really know what they were trained on, or we don't fully know. And beyond the potential liability for enterprises that would use that, it's also you can't be certain about the kind of images this model would generate. And I just remind you that, when you train an AI model, your model is kind of in some way representing the data it was trained on. And as we know, like the internet has a lot of toxicity, it has a lot of, NSFW, not safe for work content. The model we've built was trained completely on clean data that is safe and commercially safe as well. So once you use this model, the images it generates are fully licensed for you to use, as long as you, of course, paid for access to the model. So, that's very exciting. The other reason I think it's really exciting is, in my mind, for just generative AI, like the next frontier is multimodality. And you can even say that we're already in the midst of that frontier, right? We can see GPT-4o, right? Omni is able to do a pretty good job handling not just text data, but also image data, audio data, and also output, these modalities. And I'm excited about enabling enterprises, right? Not just the consumers, but enterprises to leverage this tooling. And us at Mosaic AI having on one hand, DBRX and all these great language capabilities, and now also the image AI model with image capabilities, you can imagine our next step would be to fuse these in different ways. So our customers can have a model that is capable in more than just one modality. And that's, that's super exciting. The other thing that is great about this model, I think it's super performant. It generates images in about 3 seconds, which is, according to our benchmarks, significantly better than some of the other offerings out there. And then, of course, it's fully integrated into the Databricks platform. So I can envision a lot of super interesting use cases of customers who have a lot of data stored on Databricks with the model available to the foundation model API. Customers are going to be able to implement a lot of great use cases of leveraging that text data they have, generating images, porting this back in, and using it for different, application use cases.
Is this model available for general availability, or is it in like pilot stage?
Currently, it's in a private preview, and we are starting to roll out access to select customers. And I expect that, within the next couple of months, it's going to be publicly available. We really care a lot about AI safety, and especially because most of our customers are enterprises, so they have a reputation. We have a reputation to withhold, so we're trying to be responsible by rolling a model like that is pretty capable, rolling it out gradually. But definitely our intention is to open it up to as broad use as possible.
Gotcha. Are you guys following the same step that Adobe did with indemnifying the client, or like, is there any plans to do that?
Yeah, so I'm not sure exactly what Adobe did, but our process, we have a responsible AI framework that we implement internally. We're doing red teaming. We have a dedicated red team. So we're doing red teaming against the model, and that was extremely helpful in identifying edge cases, potential challenges, and really just making sure we, within the company, understand the opportunities, but also risks of the model. And there are, beyond the red teaming, we apply gradual rollout to customers, and we make sure customers understand, right, the risks of the model, the challenges, and we also make sure to get their feedback on the model, problems, issues, etc. And then we basically, just like any other good old software development, right, iterating on the feedback quickly until it's rolled out for public availability.
So at the keynote, one of the coolest highlights was a demo by Casey, who Jensen nicknamed her the cookie lady. Can we go over what that demo was? Because I thought that was really interesting with the agents, how everything was very streamlined and easy to use.
So Casey, aka Cookie Lady. Casey, by the way, is our product manager for the AI platform team. And basically the demo, so just for the audience, the demo was about, hey, how can I build a system that handles a task? I think the task there was about, if you're a small business owner and you want to kind of build some campaigns on social media, and do some analysis, later on do some analysis on how your business is running, and how are your product consumed. And the demo basically built an agent that was able to handle the task. And one of the tasks there was, again, the social media campaign. So starting with a simple text prompt, generating the copy for social media, generating images with image.ai, and publishing it on social media. I think the example was Facebook or Instagram. It was a really cool demo. I think people loved it. What we try to do is kind of highlight the notion I mentioned earlier about compound AI systems, right? Because one key thing that was clear in that demo, it was more than just using a single model to generate some, copy. It actually used multiple iterations against the model to both generate the copy, improve it, reason about it. It used tools. Some of these tools, for example, pull data from a SQL table. One of the other tools actually generated images with image.ai. And that's all falling under what we call the agent framework. So the agent framework is our generalization, Databricks, of things like RAG design pattern. What we found is that customers, to build reliable production-grade AI systems, they have to build that compound system we spoke about earlier, or there are LLMs or maybe other models, right? There's something that chains everything together. There's a way to, of course, evaluate the quality of that application as well. But also, there is the ability of these models to use tools. And that's one of the...
I think that's the key point.
Yeah.
You supercharge your LLM infrastructure by having these tools.
Exactly. And tools is something we are super excited about at Databricks. First of all, because it helps build better systems. It helps to automate things better. But the other reason is that we really feel that Databricks is a great platform to define these tools and have them available. Because, usually a tool is something you define so that the LLM can get better context for the task. Usually getting more context means getting more data. Now the data is already on Databricks. So we want to make it super easy for you to make your data available for the LLM to use. And so a good way to define tool would be to define, functions in Unity Catalog. These functions have a description, have a signature. With the LLM capability for function calling, we basically are tying these things together. So once you define your functions who are capable of accessing your data on Unity Catalog, we just integrate this definition. Once you allow the model to access these functions, you just integrate all this information about the signature of the function, the description of the function. So it's available for the LLM using kind of traditional function calling. And I can also explain a little bit more about how function calling works. But once the model is aware that he has access to certain functions, he understands what these functions do, he understands the signature of this function, and he has a license, an approval to execute this function on our behalf, we can do amazing things. And that's what the demo was about. So again, as an example, one tool was just reading data from a SQL table. Another tool was accessing the image AI model generator with a specific prompt, and chaining these things together, or integrating these things together, allows the model to handle, a query to accomplish a task by basically making multiple invocation of these tools, aggregating the output from these tools together, and then generating basically executing on the task. In that case, in the case of the demo, it was taking a simple request for creating some kind of a social media campaign, and the model figured out the copy for the campaign, generated the images for it, pulled in some data, and then actually published the campaign on social media. I think in this case it was in Slack, but the idea is you can take the same thing and just tie it to an API that just publishes on social media. This is super exciting. We already are seeing customers experimenting with these things, and that's one of the areas we are doubling down on, enabling customers to build autonomous agents.
Yeah, so at last year's Databricks, I noticed that the big talk was around just LLM models, right? So you do a query into a model, it spits out something. That was like the big hot thing that happened last year. And then 6 months ago, like the big hot thing was like RAG. Everyone wanted to do RAG. now it looks like there's a lot of movement into like agents, fine tuning, building pre-trained models. Where do you see the market head towards in like say like the next 6 months?
I think agents is already gaining a lot of momentum and will continue gaining momentum, probably even accelerate. And it's just, you know, again, what we learned just talking to many customers who are trying to apply Gen AI applications to build these applications is that, like we said earlier, the model is not enough. You need a system. And this system is really an agent. Now, you know, RAG is like a very hot topic, but the reality is that RAG is a private case of a general case. You know, RAG is retrieval augmented generation. You use an LLM with some kind of vector search, vector embedding. You put these things together so the model has better context about the task it tries to achieve or the input it needs to handle, so you get better results with less hallucination, etc. But retrieval is a tool, right? And what really RAG is about is, or the general case of RAG is really, rather than retrieval augmented generation, it's tools augmented generation. You augment the process of generation by giving the model access to tools. Now for RAG, you know, that tool is retrieval. But there are so many other tools that are useful, starting from the basic one that all of us use regularly, right? Web search. You can already see ChatGPT using web search as a tool. You have retrieval for index-specific documents. Think about code execution, right? If you ask an LLM today to compute kind of some complex arithmetic, it would usually get it wrong, even the best model. But if you give that model an access to a tool that is a calculator or code execution, the model would actually generate code that handles this arithmetic, would run that code in a code interpreter tool, and then spit out back the result. Think about someone trying to build something like, you know, a travel companion or travel planner. You know, the model doesn't know what is the weather today in Atlanta, Georgia. But if you have a tool available for the model that is a weather, you know, API tool, the model will just call that API, get the up-to-date result, and render it into the response. So I believe we're going to see a whole set of tools, really APIs basically, that are designed for consumption by AI models and to standard interfaces like what we build in Databricks, or just integrated so the models are capable of calling these. And that's kind of the underlying technology that enables that is function calling technology, which is already available today. That's one of the things actually we've announced. I think that might have gone a bit under the radar, but there is a lot of very serious heavy lifting into getting the models to be able to understand that functions are available and call them in the correct format and all of that. So that's a fundamental technology that enables that, and that's what an ecosystem of tool is going to be built on. And again, we at Databricks are building an index of tools and a way for our customers to very easily build these tools as functions in Unity Catalog, and then it's very easily making it possible for our customers to make these functions available for the LLMs. And again, that was kind of the demo was showing that.
I'm curious as to your thoughts on like the whole pre-trained LLMs. Like, what is it? When would you use it? And more importantly, like for companies that are going about their AI journeys, like when should you be concerned about using a pre-trained LLM versus something that's off the shelf?
Yeah, that is a great question. You know, back when we started MosaicML early on, our first product was a product for companies to train their own large AI models, and later on we kind of focused on LLMs because it was getting so much momentum. And today this service is available on Databricks. It's actually growing very quickly, but it's definitely not for everyone, not necessarily required. So maybe first I'll kind of explain what pre-training your own model means. It means taking a model architecture. You can invent your own, or you can take one of the open source architectures like DBRX as an example, or Llama 3. And then basically with your own curated data set, training this model from scratch. So basically starting from random weights all the way to kind of a high performing model. And then typically it means after you're done with pre-training, We're still doing some fine-tuning with RLHF or just instruction fine-tuning. So the model kind of behaves well in a conversation. This is a process, depending on the model size and the amount of data you have, that can take, weeks or months, and it can cost from, 5 figures in dollars all the way to tens of millions. It's definitely not for every company, right? Not every company is willing to spend this budget. Not every company has this amount of data, and honestly, not every company has this need. Because it's such a heavy lift. And I can discuss maybe later a bit about how we're making it much easier on Mosaic, but still, it is a heavy lift regardless. So when would you really need it? You would need it basically if, the models that are out there today, both the closed models and open models, are not catering to your business needs. And one classic example is human languages. Most of these models today are trained on what we call high resource languages. English, some of the European languages, and at least for the models coming from the Western Hemisphere, that's pretty much it. If you need a model that can handle, Indic languages, an example, or, Middle Eastern languages, the models can handle, today's models can handle it somehow, remarkably, but it's not that good. You don't get the same quality as you're getting with, high resourced, Western languages. So one key use case, and where we've seen a lot of demand for our platform, is companies in Asia or the Middle East that are trying to train models that would cater to local markets. One, public example is Ola. Ola is one of the largest private companies, largest startups in Asia, coming from India, very successful. And they've trained on MosaicML, on Mosaic AI platform, they trained their own large language models that can handle a dozen or more, languages that are in the, used frequently within India to power their customer base. We have other examples. Many other companies in the Middle East and in Asia have been using the platform to train. So this is one example. The other kind of example is domains that they may use English, but it's a different English than what you and I use regularly. Think about legalese, right? Whenever I need to read a legal document, I feel like I read it, I can understand the words, but I don't understand the semantics.
Yeah.
And I think many people feel the same. So this is definitely an area. There's actually some very interesting startups operating in that space. But again, that's where we want to pre-train from scratch on that corpus, so the model gets really good at this, this kind of legalese. Similarly, healthcare is kind of similar. Finance, some financial data is similar. So that's when you want to think about whether you want to pre-train your own model. The other consideration is the reality is that when you use both open models as well as closed models today, you have no idea what data they were trained on. And like what we discussed earlier with image generation models, right? That is a concern for some companies because potentially the model was trained on, language data that, doesn't fall within the requirements of these companies. And they would want to fully control, some industries like security would want to fully control the training data, which gives them some level of control over the output of the model. So think about the security domain as an example. Think about vulnerabilities like data poisoning. It's actually a very interesting attack that exists today for language models. And
I do know that like nation states are attempting to poison other nation states' LLMs. So that's a huge problem because if you know when the time in which they're going to pull that data, you can go in there and just like momentarily change up the information. And it just has to be very brief, only to the point where the scraper hits it and then it can revert back to its original content. So that's like of huge concerns right now in terms of national security. So I have a lot of government friends that are very concerned about those types of attacks from our geopolitical enemies.
I think this is, one, we're talking about AI, but there is a huge domain in computing, software, cybersecurity. And I think the cybersecurity world has not fully woken up to what AI means. I'm seeing more and more companies that are trying to, bring products that offer, security products for the AI domain. I don't think we're seeing enough of these companies. And I think there is a lot of vulnerabilities that we're actually not even aware of. I mean, data poisoning is one that has been kind of a bit up in the news recently, but there's apparently, others like prompt injection attacks. We just talked about agents earlier and giving them the capability to autonomously invoke tools. Obviously, this creates a huge security concern, right? Imagine if someone can, somehow engineer a prompt that makes the LLM invoke some tool in a way that is malicious. I mean, this is like similar to SQL injection, code injection attacks, right? So I think we need and we'll see more companies that offer some kind of, mitigations for that. But anyway, taking a step back to pre-training. So, those are two, languages, distribution, and then data security. Those are some of the key reasons why companies want to pre-train their own models. And the other thing I would say, state the obvious, is when you pre-train your own model, you create a pretty powerful and important IP for your company that no one else can access. I mean, if we talk about frontier models or open source models, you can use them, your competition can use them as easily. When you pre-train your own model from scratch, actually, if you have the right data and kind of you train a good model, you have a pretty significant IP. And definitely, all of our customers, when they pre-train their own models, that's what they have in mind is also, okay, creating really unique IP that is not that easy to, generate by our competitors. So that's kind of the business reason why people would do it. One of the exciting things, again, I think that announcement maybe went a little bit under the radar in today's keynotes and discussions, but we are really working hard to simplify as much as possible the complexities around pre-training our own model. I mean, if you look at the companies that are training their own models today, they usually have fairly large teams of machine learning infrastructure people, machine learning researchers, because that's what you need to, need to get these folks together to have the right expertise. Plus, you also need a fairly large GPU cluster, and of course, a lot of data. Now, we're trying to kind of handle the first two aspects, rather than you needing a large set of machine learning infrastructure people and researchers. We try to handle all of the undifferentiated heavy lifting. So setting up a cluster with thousands of GPUs, managing it, there's a lot of complexity that goes into large-scale training, from sharding the model to doing data parallel training, pipeline parallelism, model parallelism. All those things are fairly complex. And then, of course, just managing that cluster, because I can tell you that usually doing a training that lasts a week or more, at least one GPU is going to fail. Depends, of course, on the cluster size, but it's pretty hairy. And we've invested a lot of time and effort to build fault tolerance into the system. So when GPU fails, we actually have a mechanism that detects it, pauses training, swaps out the failing GPU or the failing node, swaps a new one in, resume from the last checkpoint. That's all done automatically for most of the cases today on our platform. And we got a lot of experience by, pre-training the MPT series of model, DBRX, Image AI. So we're trying to really make it as simple as possible. And today on Mosaic AI pre-training platform, you can pre-train 4 different flavors of DBRX, starting from a small DBRX, 9 billion parameters with about 2.5 billion active. It's an MOE model, just like the big DBRX, just kind of smaller scale. And going all the way up, I think the next size, like medium, is 20 billion parameters with like 5 active, going to 40 total, and I think 10 active, and up to 70 billion parameters with 20 active. So very efficient MOE models. And all you need to do to pre-train them on the platform is call a simple API where you point us at your training data in a cloud bucket like S3 or Azure bucket, provide a target bucket to store the checkpoints into, configure your favorite experiment tracker like MLflow or weights and biases or whatnot, and that's pretty much it. and you specify these things, you call the API, and probably the most expensive and complex API call in history, because when you call this API, what it does, it triggers a fairly large, hundreds of GPUs are going to be very busy for, depending on the model size, but from a couple of days to a couple of weeks to train this model for you. So that's one of the things I'm very excited about, because just make training large models much more accessible, right, across the industry.
Gotcha. So what I'm hearing is that you guys have built like an abstraction layer that goes on top of your system that just makes it easier to just build your own models,
Yeah,
right?
exactly.
That's the way to do it. I love abstraction layers so much because I don't got time to go in the weeds. I have like deadlines to hit, or sometimes I just don't want to hire a SME. I just want to be able to just get off the ground running. So I absolutely love the fact that you guys have gone the abstraction layer route. Can you go over at a high level for viewers, what's the difference between fine tuning and then pre-training? And then in your opinion, your point of view, when should you be using one or the other as like a business executive for your like line of business?
Yeah. So technically, it's kind of at the high level. When you fine tune, you take a base model that was already trained and you teach it to do usually one specific thing much better. So an example would be, I have a standard task, which is maybe take a document and convert it into JSON with certain fields. A general purpose LLM would handle that. Depending on the task, maybe it will be okayish, maybe it will be poorly, but it can handle it. But then you need to get good results, you need to have kind of a fairly large frontier model. With fine tuning, once you provide for a task like that a couple of hundreds or thousands of examples, you can actually get a small pre-trained models and get it to perform really well, usually at the level of kind of the big frontier model. So fine-tuning would be good for something like that, as long as the model is capable in the the human language that you're talking about, and as long as the domain is not really like a unique domain. And I would always recommend, by the way, starting by try out just like in software development, try out the simplest thing, see how it works. If you're lucky, it works well. If not, you go to the more complicated solution, which in this case would be fine-tuning. If that also won't get you to the quality you're looking for, that's when I recommend, okay, you probably should think about pre-training. And with pre-training, you can cater to things like, hey, maybe the distribution of the data I'm inferencing on, the language or the domain, is so unique and nuanced that you can't get good results out of a general purpose model, even when you fine-tune it. And that's when you go to, you would use pre-training. Again, I would always recommend start with the simplest route and then gradually go to the more complicated one. The other thing that I've noticed is that, it's interesting, our customers for pre-training are, they're all over the place. Well, I definitely see a trend where there are a lot of startups who are really working hard to build unique, differentiated technology in things like healthcare, legal, or in kind of regions, geographies in the world where the languages are not well represented. Or there are very large organizations that have treasure troves of, precious data, and they want to leverage the data to have a differentiating advantage. So those are like kind of, just to illustrate to the listeners some of the use cases where customers are trying out pre-training. I would say, just in a general, even taking a step back, you can get a lot of good results just with good prompt engineering. And one interesting trend is also we're seeing is that context lengths are becoming so long. I think Google's Gemini has 1 million.
It's 1 million. Yeah.
That's incredible, right? So 1 million is about 10 really long books. So I think one interesting trend is context lengths will continue becoming better. I almost feel like the context length become almost like an alternative to fine-tuning in a way, because they can provide enough context and examples in a very long context that some way, may actually cater to the same need we have when we fine-tune. So that's an interesting trend. I do think that now one limiting factor is just, using long context at scale is extremely expensive.
It's so expensive.
Yeah.
In fact, I don't even know how Google even does it, right? So I'm thinking like they probably built like a 32K context window-sized LLM, and then they just compressed it. I'm assuming that's how they built it, but I have no idea how these companies are building these very large LLMs without training it, right? So it's like a good example would be like Anthropic. They were one of the first to break the 100K context window size. There's GPT-4o, which is like 128K, I think. We've already hit 1 million. I think we're gonna go like 1.5, 2 million. What happens when you go so large that you can just, just brute force and throw everything into the text prompt? Where do you see like context window size going in terms of like LLMs?
Yeah, I think they open up exciting window of opportunity, like I said, where you can actually customize the model quite a bit without fine-tuning it, just with prompt engineering. But there is a real practical barrier for people. So it's nice, PR, but today it's not that useful because of the cost and the latency as well. There are some really interesting technological advancements that are happening now, and we're also looking into these. Let's talk about the challenge. Why handling such a long prompt is challenging. So when you do inference for an LLM, you need to compute something called KV matrices. It's kind of the core part of the transformer architecture. And basically, for every token, you generate these two other, there's 3 vectors generated, but 2, the key and the value. This is part of why LLMs require so much memory and compute. However, you can actually, once you've calculated the KV matrices, you can actually cache them for future use. And that's what's called the KV cache. Now, every production-grade inference system, including Databricks, many others as well, has KV cache implemented today. However, this KV cache is used within the same, autoregressive prediction. It's not maintained across invocations. And as long as it's, as long as we're not reusing it across invocations, then the cost will continue to be very high. Basically the cost grows linearly with the prompt size. I think what would be very exciting if we are able to engineer our way into caching the KV matrices across calls. So just going back to our example of using a very long prompt, imagine if you have a very long prompt to set the context for the model, but that prompt is the same across multiple invocations. And what if you were able to, or the system you're using for inference was able to cache this long prompt so that the cost would still, of course, be higher than a small prompt, but also you don't need to regenerate these KV matrices. You don't need to recompute them. So the compute requirements went drastically down. And I think once we have innovations like this, and like others where you compress the KV cache and do other things, long prompt handling is going to be cheaper to use, more accessible, faster, and that's when it might be more usable. But until we have all these engineering innovations in place, long prompt is going to be a nice PR statement, but not really useful in reality.
Yeah, I would hate to see someone like fill up a really large prompt size window, and then I don't know if this is still happening right now. You have a lot more insight than I do, but whenever this is what I noticed, but if you ever fill up a context window, like the center gets really fuzzy, but then the front and the rear gets really crystal clear. Is that still happening right now?
Yeah, that's known as the lost in the middle challenge. There's a really nice paper that describes it and does some experiments that I encourage the audience to check out. I think there's been a lot of attention to address that problem, and like when we trained DBRX, we actually paid a lot of attention to it, and our evaluations actually looked specifically into it. And in our technical blog post, we mentioned how we measured it and how we tried to mitigate that problem. So I think it's something that is going to gradually go away, right? Everyone has their attention to make sure that even for a long context, the model doesn't lose the focus on the different parts of the prompt. And what's interesting, that actually was public. I don't know if you saw that, but I think in the last Anthropic Claude release blog post, they mentioned how they evaluated the model on this, kind of having the interesting information in different parts of the long prompt. And the way they did it, they had some monotonous kind of topic in the prompt, and then they just injected something completely unrelated about toppings for pizza in different parts of the prompt. And then they asked the model about that detail, about the pizza topping. And one of the responses of the model was that he answered correctly about the pizza topping, but then the model also generated text saying, but I think this is some kind of a test because the pizza topping is completely unrelated to everything else in this document. And it's almost like the model is gaining some level of consciousness, right? And figuring out that it's being tested. So that was a really interesting example. Of course, no consciousness, but just to illustrate kind of that companies who are building models are paying a lot of attention to the ability of the model to identify the important information throughout the long context.
This is so cool. Like, what if I needed to get in contact with you? How would I do that?
Yeah, I'm available on LinkedIn. I'm pretty sure I'm the only Hagay Lupesko on LinkedIn. So just, hit me up on LinkedIn and be happy to connect and, chat more.
Well, thanks so much for being on the show. Do you have any like final thoughts on like the cool summit that's happened so far?
Well, first of all, thanks for having me. It's, I think, my second time, and it keeps on getting better. I think me and everyone else at Databricks, we're super excited about what's going on in AI, super excited about helping our customers leverage AI to build fantastic application for their businesses. And I'm just super excited, for all of us, what's next in AI.
Very cool. And until next time, stay curious.